All right, welcome everyone. My name is Ali, and we're going to talk about infrastructure as code on Oracle Cloud Infrastructure. So I want to start with a brief recap of the Oracle Cloud Infrastructure, so we understand what we mean by infrastructure when we talk in this context. So we operate our cloud in the form of regions. A region is a metropolitan area and serve different geographies. They help to provide disaster recovery in the cloud. Inside the region, there are multiple fault-isolated data centers, and we call them availability domain. Each availability domain provides high availability within the region. And usually, a region consists of 3 ADs, and they are each isolated from each other. The ADs are wired over private dark fiber, and there's very little latency between them. So usually, between the ADs, there are one-way latency of around less than 500 microseconds. And this makes the Oracle Cloud Infrastructure quite suitable for scale-out, fault-tolerant architectures like Oracle MAA or Cassandra, these kind of systems. Now, inside an AD, what we have done is that we've built one of the best public cloud networks. It's big, flat, fast, and predictable. What we mean by big is that it can scale to almost 1 million network ports within one AD. What we mean by flat is that it's not oversubscribed, so we get pretty good latency between hosts in the AD. And fast, we support up to 25 gigabytes per second over the network bandwidth between two hosts. Now, on top of this physical network, this is where you would start defining your own virtual network. And we have made some quite drastic changes in terms of how virtual networking is done in the cloud. We call this off-box virtualization. Essentially, we offload the hypervisor from the network and the storage I/O management. This basically gives us 3 advantages. 1, it gives us better performance and avoid the noisy neighbor effect. And 2, it gives you a flat network, so there's no difference whether you're running a virtual machine or whether you're running a bare metal instance. And 3, it gives us better security by limiting the processes that are handled by the hypervisor that are shared among tenants. And then finally, on top of this virtual network, this is where you would be provisioning your services. So these are your virtual machines, your bare metal, your container, your block and object storage, your load balancer, etc. So when you build your applications, you will be using these services to build them. So to go in, this provides us a list of infrastructure services that we have on OCI, we call it. And we are starting to roll out what we call PaaS services as well. So last week, we rolled out what we call the Oracle Container Engine. So that's basically our managed Kubernetes as a service. So you don't need to build this from scratch yourself. Right. So when we say infrastructure is good in the context of OCI, what we mean is that you need to choose the region where you're going to be running this, the virtual network. So this is where you would be defining your subnets, your security rules, your routing tables, and then the kind of services that you would be using. So whether you're going to be using virtual machines, bare metal, whether you're going to be using load balancers, etc. So this is, when you're doing infrastructure as code, this is what you will be basically configuring, right? So what is infrastructure as code itself? So I want to dispel some myth first. So it's not voodoo. It's not Jedi hand-waving tricks. This is not the droids you're looking for. It's not Harry Potter hand-waving kind of exercise either. And it's not looking at a GUI and clicking and doing certain actions. I mean, if you guys were in the session this morning, you heard Aaron saying it's like watching paint dry. ClickOps is like watching grass grow. So you can choose which one is slower, you know. All right, so what infrastructure as code really is that it helps us it enables us to define and handle our infrastructure and application just as you handle code. So you can code it, you can version it, you can test and debug it, repeat and reuse. So this is what you will be, what you do with infrastructure as code. And because you're handling your infrastructure as code, so what it helps you, what you can do is that you can do code reviews with it, you can do automated testing, and you can include it as part of your deployment workflow, right? So some of the benefits of infrastructure of this technique is you can reduce. It helps you reduce the cost of your IT operations. So with automated provisioning, it helps you eliminate costly rework due to configuration drift or human errors. And because you are doing automation here, what you can also do, a side benefit of that is that you can do large-scale provisioning very quickly. So you can speed up the provisioning and teardown of your infrastructure and applications, so you can make changes almost as natural as breathing. So there are no dramas whenever you need to make certain changes. And this leads to increased team productivity in your organization. And then finally, I mean, it's not an exhaustive list, so I'm cherry picking here the benefits of this technique, but it helps you maintain compliance and consistency by using standards, especially if you're operating in certain industries that require, like, you need to maintain some kind of HA policy or disaster recovery. It helps you maintain all this kind of stuff, right? Okay, so I want to introduce you to Terraform. So Terraform is our preferred infrastructure as code tool. It helps you build and manage your infrastructure quite elegantly. It's open source and cloud neutral. So, if you have asked us, say, probably a few years ago, what's our answer to infrastructure as code, would probably have said, you guys need to install JDeveloper and you need to store the artifacts in a database or something. So that's not our approach. So we are using Terraform. So basically you write code, you use a version control system to store the code. So Terraform itself supports multiple providers, so OCI, Classic, and some of the PaaS services, which we are starting to add support for now. So very recently, we provided support for DBCS and JCS, and there's more coming along the way. So it also supports other cloud vendors like AWS, Google, and Azure. So that means skill set in the market should be pretty available. And if you're doing private cloud deployments, so you can deploy to Kubernetes, Docker, or even OpenStack as well. Terraform has a declarative syntax, so you don't do you forget about the procedural. So you define your end state. This is my end state, and it will figure out how to get there. And one thing I really like about Terraform is that it sort of follows the Unix philosophy pretty well. So it does one thing and it does it pretty well. So it doesn't attempt to boil the ocean. And because of that, you can configure it and use it with other configuration management tools such as Chef, Puppet, Ansible, Cloudinit, this kind of softwares, right? So Terraform itself, the way you install and use it is just a simple binary that you install on your laptop or on your servers, and you get it to execute certain commands. So apply helps you either build a net new infrastructure or make some changes to an infrastructure that's already been managed by Terraform. Destroy, obviously, get rid of whatever provisions, so we're going to try and do that a bit later. Format helps you to neatly format your code so it looks quite nice. Init helps you to initialize a working directories, especially if you're going to be using certain plugins. Output gives you the outcome of that of a Terraform run. So if you need the IP addresses or certain IDs, etc., so it helps you print that. You can use that later on. Plan helps you to generate and show what's going to happen if you use and apply. So for example, you change certain parameters around your project, it helps you to figure out, am I going to add a new server or am I getting rid of certain stuff? So it lets you know what's going to happen, right? So starting a Terraform project is pretty easy. Now, one thing it does is that it stores what we call the state. It stores the state of your infrastructure in a local file wherever you are running this. So it's, and if you don't, usually you don't put that as part of your versioning. So it's on GitHub when you're starting a project, it helps you automatically pick a git ignore template, so it automatically does not include those state files. So some confidential information are not shared in your Terraform project, right? So the Terraform code format is actually pretty simple. So you start with a component. So a component can be either a resource or a data. You then specify the provider. In this case, this is OCI, and the type of provider. So here we are creating a virtual network, and then you give it a name, right? A resource will also have a bunch of attributes. So some of them can be mandatory, some of them can be optional. Now, if you look at this a bit carefully, what you will notice is that if it's quite similar to an object-oriented definition. So this is my object, and think of this as the constructor with the necessary parameters to pass to the object, right? So it's sort of pretty similar. Terraform has 3 types of variable. The first one is string. So by default, it assumes that any variable is a string, and you can specify a default value. The second one is a list. So a list is essentially an array of string. Now, if you are going to use a list, you need to explicitly say that the type is a list, right? And the third one is called a map. So again, a map is a key value pair. So if you're going to use map, so you need to explicitly say that this variable is of type map, right? So pretty simple, 3 types of variable. Right? Now, what you do with these variables is that you need to pass actual values to these variables. So usually what you would do is that you can load it in a number of ways. So you can set certain environment variables. So if you want to do that, you would prepend it with a tf-var. So when you run it from command line, what Terraform would do is that it will, you see that private key path, so it forgets about all this bit, and then it loads the value of my SSH key into this value. So it's available for Terraform to use. Otherwise, what you can do is that you can use a variable file. So by default, it will look for a file called terraform.tf-vars in the current working directory. So this file will contain the list of variables. So for example, the load balancer shape is 100 megabytes per second, the volume size is 50, and whether you want to have an HA here or not, right? Otherwise, what you can also do is that you can, if you're storing that variable file somewhere else, you can, and you have named it differently. So what you will do is that you need to pass as an argument the location of that var file. So you can see over there, so terraform-var-file my variables, only if 1, you have named it differently, and 2, it's in a different location to your current working directory, right? Pretty simple. Now, Terraform has a very important feature that's called modules. So it helps you build your infrastructure in modular fashion. That brings you, that gives you a certain benefits. One, you can, given the type of infrastructure you're doing, you are going to be building. So you're talking about network, security, compute, maybe configuration management, and all of these tools they use different kind of software or frameworks. So for example, Chef uses Ruby, right? So what you can do is that you can assign various parts to people who are specialized in particular areas. So you assign the networking part to the network engineers, for example. You assign the provisioning to people who are trained with Chef, this kind of stuff, right? The second thing is that it helps you isolate certain features and also increase the reuse. So you can think of modules like a combination of methods and packages in Java. So it has inputs similar to method parameters, and you can name it in any file. So the name of the file in Terraform actually does not really matter, unlike in Java, right? And the second one, it has output. This is similar to return. So you want to return something or print something for somebody else to call this or get the value. Again, the name of the file does not really matter. You could arguably put everything in one single file, but that's not really good for maintenance. Excuse me. Now, why I say it is a combination of methods and packages, because one, it has the inputs and outputs, but unlike Java, Java package does not have outputs, right, or inputs. So, but what it does is have a particular folder structure. So Terraform has something similar. So how you define a module is you give it a module, for example, and then you give it a name, and then there's only one required parameter. So this is the source. So you're saying where, relative to where you are, where that module has been defined. So this is, the example I'm using here is a relative file path, but you can also point it to another GitHub repo, for example. So that allows reuse, basically. Right? Now, on the left, what you see here is the name of parameters that are expected by the module. So this particular module is expecting these values, these values, right? And on the right, I'm passing the actual values of the parameters to these over into the module, right? So what you will notice is on the right, specifically, so there are two types of things in between the commas, right? So everything that's enclosed between curly braces and a $sign, that's an indication to Terraform that it needs to interpret and interpolate. So it needs to evaluate something to come up with a value. Otherwise, it will just assume that it's a string, right? So the second thing is that everything that's prepended with a var within the curly braces, that usually indicates that it's a variable. So var, that's something. Although you can also do direct object references as well. All right, so now over here, lastly, what I'm doing, you can see here, is that I'm taking the output of this module and then passing it as a parameter to this module called Bastion, right? So for the Oracle Cloud, you need to, depending on what kind of infrastructure you're using, you need to define a provider. So for OCI, you would be just providing this, a provider at OCI. So for some of you who attended the container lab earlier today, so you would have seen something like this. So you need to pass in the tenancy ID, the user OSID, the fingerprint, the region where you want to provision these infrastructure services. If you're using the classic one, so what you would do is pass in your username, your password, your identity domain, and the REST endpoint. And then we are now coming up with some of the PaaS services as well. So, like for example, you need to have a Oracle database in the cloud. So rather than you creating a VM or using bare metal and then you install the database, etc., you say, all right, so I want to use the Oracle PaaS, and this is my database endpoint. Create this for me, and all these are the parameters. So it does that automatically for you, right? So the Oracle Cloud is pretty much API driven. So API is a first-class citizen there. So it's not designed as an afterthought. So that makes it very well suited for using it provisioning your infrastructure using code. What Terraform brings to the table is that it simplifies the syntax to provision your infrastructure. So you don't need to write the native JSON objects and pass it to the REST endpoints, right? Excuse me. The second thing that Terraform brings is that it takes the procedural aspect out. So you don't need to figure out, I'm going to be creating a compute, and I'm going to be passing it to this subnet. I need to access it. So I need to create the VCN first, then create the subnet, then set the security. So it takes that procedural aspect out. So you say, oh, these are the things I need to create. It figures out the order of dependency and the way in which these API need to be invoked. And it also makes it quite easy to update an existing deployment. So for example, let's say you have a compute that is running a pair of servers that's running a web server. Suddenly you experience an increase in traffic, so you want to double this. So all you need to do is just change your parameter, run the apply, and Terraform will figure out that, okay, I need to provision an additional pair of web servers, and it will do that automatically for you, right? Terraform also helps you with the reusability, with modularization and parameterization. So if we still have a bit of time later on, we'll take a look at that. And then it helps you with the testing of your infrastructure as well. Finally, as I said earlier, it makes it easy to combine with other configuration management tools like Chef, Ansible, Cloud Init, Puppet, etc. So let's go to a demo. This is usually my favorite part. Right. So what we are going to do is that we are going to provision a redundant NAT instances across 3 ADs. Now, if you remember earlier from my introduction, a region consists of 3 availability domains, which are essentially 3 data centers in a geographical area, right? So what we're going to do is that we're going to create an infrastructure in a region. We're going to create a VCN and give it this CIDR value, right? And we want it to be publicly accessible. So that means provisioning, creating an internet gateway as part of this VCN. And we're going to create a bunch of compute within the 3 availability domains. So for argument's sake, we are going to do a traditional 3-tier architecture. You can do whatever you want, right? But this is roughly what the demo is. In the actual demo, I'm not going to be provisioning all of this, just one server is. But the key point about all of these guys is that they are running on private subnets. So that means they are not publicly accessible. You can't dial in and they can't get out at this point, right? So the first thing that we want to do is we want to be able to get in. So SSH or something, right? So to do that, we create a public subnet, and we allow a SSH access. We call this it's a pattern that we call a Bastion Host. So it provides very minimal access, typically SSH, and then you can use this as a jump host to SSH into the host and the internal subnets. Right? So now at this point, what we are able to do is that we're able to get in, but we can't get out, right? So to be able to get out, we provision what we call NAT instances. So the NAT instances, what it will help the computes on the internal servers do is it will have IP forwarding enabled. The traffic from the private subnets will be directed towards these NAT instances, and the traffic will be routed accordingly, right? So to do that, what we do is that we update the routing tables of these private subnets to point to the NAT instances. Now, I've I've started from creating the private subnets, the Bastion host, etc. The way Terraform does this is that it automatically figures out which one I need to provision first. So you can see that because the routing tables of the private subnets need to point to the NAT, so that means I need to provision the NAT instances before. And in order to do the NAT, I need to provision the subnet of this guy first. So Terraform does that automatically. So it creates a graph, basically a deployment graph, and then figure out which one it needs to do first, all right? All right, so let's take a quick look at the actual code. All right. So this is my project. So this is my Terraform.tf version. Can you guys see properly? Yeah. Okay. So I'm specifying my CIDR value, the name of the VCN. We'll come to these guys a little bit later. The shape of the Bastion host. So typically, you want to keep the Bastion does not need any huge amount of capacity, so you can keep the shape pretty small. And then where we want the HA to be, where we want the instances to be provisioned. So each of these are in the various availability domains. So we want this to be true, true, true. And the last two for Redis, which is the instances on the private subnets, right now only one in the availability domain 1 has been provisioned, right? Now, this is my variable file. So my variables definition is in this file. So like I said, the name of the file itself doesn't really matter, but usually give it something indicative to know what you're doing, right? So I'm specifying the tenancy ID, the user associated, etc. So when I run the Terraform here, the Terraform command here, the values that I've specified here are loaded into these, and then they get executed, right? Now let's look at my main. So I have a number of modules here. So the first one I have is a VCN, and I'm passing all the values that were loaded from my variable file into this module. So if we expand this, you will see that it also has its own set of variables. So this means that these are the ones that it's expecting to receive. These are the values it's expecting to receive, right? Okay, so let's look at the VCN. So I create my virtual network and the internet gateway. It's belonging to this virtual network. So remember earlier I was saying you can reference an object either by a variable, so var.something. So this is an example of that. So var.something is referencing a variable, or you can also reference it directly by object. So this is, because it's in the same module, so I don't need to get another variable to reference. I can reference it directly, right? So then I create a routing table, which basically says, for any destination address, send it to the internet gateway, and that's it, right? So at this point, I have my VCN created, my internet gateway created, and a routing table created. So we'll come to these guys a little bit later, right? Now that I have my VCN, I can start creating my security list. So the security list, so I want to be able to specify for each, the security lists are applied to subnets, so I want to be able to log them down. So the Bastion, I only want to allow SSH access. I don't want anything else, right? So egress is for going out, ingress is for coming in, right? So the only thing I want to do is keep SSH port, so 22 open. Whereas for NAT, it's slightly a bit different. So I want to allow ingress, so anything to come in where the source is from within the same virtual compute. So whether it's in the same subnet or from the private subnets, right? So I want to allow traffic from that, right? And then I have some, this one is for the internal private subnet, so this gets some provisioning Redis. And I also want to allow SSH access because I want to be able to SSH in later on if I need to do something, right? And I want to also be able to, let's say, other applications will be talking to Redis using Redis as cache. So Redis by default uses port 6379, so I want to be able to enable that, right? All right, so this is my securities list created. What I do next is I create the subnets. So I choose my availability domain, and I give it a name. We'll come to that one a little bit later, so that's a little bit longer discussion. And I put because it's in the Bastion host, so I can make it point directly to the internet gateway, right? And then here, what you will see is that I have a count. So a count, it basically says how many times I need to execute this bit of code here, right? But I'm not using just a count. I'm also using it together with the ternary condition. So if the value, I'm looking up in this map, if the value of this is true, then create only one instance of this. Otherwise, don't create anything. So if you remember here, the Bastion AD is 1. So if this is true, it will create one of this, right? Okay, so I'm doing this in all 3 subnets. Now, the next thing I also do is in the NAT subnet. So basically the same thing. This time I look up the NAT values, and then one thing I want to do is that I want to be able to give them a public IP. So I can get out, basically. Right? There's a couple of variations on the NAT. So this is the one I choose to do, right? Okay, then what I have is a bunch of outputs. So I want to be able to essentially reference the output of the VCN. So I need my ID. I need the IP addresses, for example, so that others can use, or the subnet IDs, right? So we're going to see that now. And so let's come back to the main. So we've done the Bastion, right? No, actually, we haven't done the Bastion. So we've done the VCN. So let's go to the Bastion module. So you can see the source of the Bastion is just the current working directory and then the folder called Bastion. So let's open that. So over here, I create a Bastion host here in 81, and in availability domain 1, I give it the name, the image that I want to use. And then here, I'm using the Bastion ID. Where is this coming from? It's coming from this variable. And this variable here is basically being passed as a parameter from the VCN module, right? Okay. So I do this for the Bastion. So now, once the instance is created, I want to be able to do something, either do some configuration, install some software, etc. Right? So the way to do that is you pass in the user data field. We are using cloud init, right? So if we open this. Cloud init basically says, all right, where is this YAML file? And if we open this YAML file here, what we are doing is that we're just echoing this string into the MOTD file, making sure the postfix services stop, and run a yum update. And when it's finished, just create a finish file to indicate that the operation is done. We don't need to do much on the Bastion host because all we need to make sure is be able to SSH, right? Now, the Bastion host itself, what we need from it is just its IP address. And we're going to see why we need the IP address later on, right? All right, so now let's go to the next one. the NAT module, as you can see, compared to the Bastion module, it has a lot more variable and parameters that it's expecting. So we are passing the user OC, the region, SSH keys, etc. So let's take a look at the NAT module. Right. So compute is more or less the same thing as the Bastion. So the only difference is that we are using a different NAT, a different user data. So we specify this here in the NATs. Now here is slightly different. So we are pointing to this NAT cloud init file, and the NAT cloud init file itself. Earlier, if you remember, we only had the bastion.yaml, right? Here we have the nat.template.yaml, and then we are passing some additional parameters into that nat.yaml. So let's look at what this guy is doing. What it's doing basically, you can tell it how to behave when the instance is being provisioned. So you don't need to figure out if you're using Oracle Linux or Debian or Ubuntu, whether you're going to use Yum or apt, this kind of stuff, right? So you just say, I don't want to do a package update, right? But I want to install this package, make sure that this package is installed. I want to set my time zone. And then what I want to do is I want to write these files in this location with this permission, with the content of this, right? So when these compute instances are being created, these files, as you can see over here, will be written with the various content of this. Where is this coming? It's being specified here. And this itself is a variable that is evaluating something that we defined a little bit further up here. So if you look here, the firewall, the template file is a firewall template. So let's take a quick look what we're doing here. So over here, we're just stopping the service. Because this is NAT, we are using this as a NAT, so we are enabling the IP forwarding. And since we are using Oracle Linux image here, Oracle Linux by default as firewall uses firewall D. So we set up the various firewall rules on the host itself this time to enable IP forwarding, right? This bunch of stuff, this is for VRRP, so we'll take a look at that later. And then we'll start the firewall D service. Okay. Now, if we come back further down here, there's a bunch of other files that we are writing. So we want to change route, notify some configuration file. We'll come to that in a bit. So now at this point, what I want to show you guys is so I had already run this earlier just to make sure we had an instance running. We don't run into network issues, etc. So I already have an infrastructure created. I want to see how I want to see what has how to access my instances, my Bastion host, what are the IP addresses, how do I SSH in, right? So I just type Terraform output. So remember one of these commands earlier, Terraform output. So it's printing out these values. So usually you would get this to just print the IP addresses, for example. But because I'm making this as a reusable module, that this one itself can be reused to provision other infrastructure. So I need to make this to output the VCN ID, for example, right? Now, if I want to SSH to the host on the Bastion host on the NAT host on 81, so I'm printing the command here. So just copy this. You guys see properly? Yeah, So you will notice the J command here, the J option here. The J is for specifying that I'm using this as a jump host. I don't want to SSH into the Bastion host itself. So this is the Bastion host. This is where I really want to get. This is running on a private subnet, right? Right, so I now command you to log in. Nope. Okay. See, it does this one, right? So I have jumped through the Bastion host into the NAT host, and you can, in this way, you can do that with your instances on your private subnets as well, right? So similarly, if I want to SSH to my NAT in the AD domain 2, right? I will do this and SSH in, so eventually it will get there, right? All right. Now, this is what you will see in the OCI console. So these are the instances that have been created. So there's only one Redis. The Bastion have been created in all of them, right? And if we go to networking, so there's the base VCN. And if I open this, you will see the various subnets that are already there, the routing tables, the internet gateway, etc. So I'm going to make a change now, right? And then I'm going to set this to true. And I want to see what kind of changes Terraform is going to do before I execute it. So I type Terraform Plan. Remember, by default, it's looking for that Terraform.tf. So it's now under the hood. What it's doing is that it's calling all the REST APIs for you, and then figuring out what is the delta between the current state and the future state, and therefore what other resources it needs to create. Right? So it's reevaluating, refreshing the state. All right. All right, here we go. So it started to print. These are the stuff that it's going to change. So it's going to add 6 of them, change 2, and destroy 2. So it tells you the impact of your changes, right? So if I execute this, so let's see what's going to destroy. Right, okay. Right, okay. I don't want to get to delete the Redis. Okay, so you can see in red that means something is going to be destroyed, and whereas the one that's in green with a plus over here, it's just going to add it, right? Okay. Now, sorry. There we go. Okay. So now we have some instances created in 3 different ADs. So there are some issues we need to consider when you provision your infrastructure, right? So the first is consistency across or your infrastructure. Configuration drift is the enemy. It's the phenomenon where servers in an infrastructure become more and more different over time, either because you are doing certain changes or due to very manual processes, somebody log in and change some configuration. That's called configuration drift. And what's important is that you avoid configuration drift at the time of both provisioning and over the lifetime of the service. So if you're doing this manually, right, you can log in into one server and then you make some changes, then you run a different set of commands, you forget one of them. So that's the configuration drift, basically. Right, so you can read a bit more about this on this link. The slides will be available to download later. Right? Martin Fowler also talks about Snowflake servers versus Phoenix. So Snowflake is something that is unique, whereas Phoenix, you can basically repeat it. So you guys can read about this a bit later. Now, your security rules as well, so you need to be able to review and audit it, as well as your network. So you want to your network engineers or your security engineers to be able to review that and test it as well, right? And if you need to allow access to certain ports, you need to make sure that your security rules on your subnet also matches that on your host. Like for example, where I was doing Redis earlier, so Redis uses port 6379, so it's listening on that port. So I need to open the port on the firewall, on the host itself on that port, and then on the security on the subnet as well, right? The second set of other issues to consider is IP address management, right? So typically, how you define your network will be the result of the type of application that you're running, the architecture of the application, the number of components, and also the popularity of the service that you're providing. So if it's a wildly popular service, obviously you're going to have to scale your infrastructure. And Stefano was talking earlier about using DevOps to scale and this kind of stuff, right? Now you can tell me, well, why don't we just give it a CIDR value of /8 and we'll have 16 million and 777,214 hosts available on your network to use, right? So the problem is that this increased your blast radius. And the blast radius is basically how far the damage spread when disaster hits, right? So if you guys watch the movie Green Lantern, there's Kilowog. He said, the bigger you are, the faster you burn, this kind of stuff, you know. This guy who's talking about on that link there, he's talking about the blast radius in terms of network switches, right? And now, while the concept, but the concept is the same. And what he said is that the bigger the size and capacity of your switches, the bigger your blast radius. So essentially, you try to limit your blast radius. The other aspect you want to consider is the number of subnets that you want to do and the size of your subnet, right? So these two, they are directly related. And you need to be very careful in terms of how you plan your network. Because, so I'll give you an example here. Okay. So 10.1.2. Zeros. 20/24. Make it a bit smaller. 24/26. Right. So you can see this is my subnet mask, for example. This is the size of the subnet. So essentially, each subnet has 26 hosts. So what it shows you here is that you have 4 subnets, and this is the total number of hosts, right? So they are directly related, right? Okay. And then another problem you might also face is what you call overlapping subnets. So you can see over there, the first one. So this is the CIDR subnet, the net mask of the CIDR. So this is the range of IP addresses for that particular subnet. Now, sometimes what you want to do is that for certain type of services, so particularly for load balancers, you want to keep the size of the subnet small. So you say, oh, well, I'm going to give it this. But what you will notice is that the range of this IP address actually overlaps with this. So which means that if you already carved this out of your network, you can't actually use this, right? So this, and then finally you can use, so there's somebody who wrote about this, so you can actually program all of this stuff and making sure that you avoid these kind of issues. So the way we do this is what I was showing you guys earlier. Where's my mouse? So let's revisit the subnets, right? So what you will notice, Terraform provides you with a function called SideASubnet. So what you pass in as the first variable is your VCN CIDR. So it's standard 0.0./16, and then new bits is the difference between the net mask of your VCN and your net mask of your subnets. And then the last one is a zero-base index. So if we come over here, right? So it's a zero-base index of the subnet when the network is masked with a. So it essentially helps you define the size of your subnet, avoid overlapping, and this kind of stuff, right? Okay. So all of these stuff directly impact your high availability and your failover, right? Now, what we want to do as part of a final exercise is bring in some redundancy and failover capability, right? So imagine one of your NAT instance fail. Your applications depend either, you need to be able to fetch some data externally, or you need to update your instances. If that NAT instance fail, these instances internally, they cannot get out, right? If a second one fail, that's 2/3 of your infrastructure that you've lost, right? So the way you can handle this is there's a protocol called VRRP, so Virtual Route Redundancy Protocol, and it's implemented by a software called KeepAliveD in Linux. So KeepAliveD basically works as a master-slave kind of function. So you run a master, then a couple of slaves, and at the beginning, when everything is fine, so everybody's routing their traffic to their own respective NATs, right? Now, what happens is that if the first one fails, you want to be able to direct the traffic from your private subnets to either the master, or basically an instance of NAT that is still operational. So you direct the traffic to there. Now, one of the problems, KeepAliveD usually works with multicast. And currently we don't support multicast. But KeepAliveD also allow you to define your KeepAliveD instances using unicast. So I need to know, in terms of provisioning, who are my other KeepAliveD instances, right? So let's come over here. Right. So what you'll notice is that all of these files here, so KeepAliveD, the template. So remember I had the package installed already. So here I creating a bunch of scripts, and then at the time of provisioning by Terraform, I'm parameterizing all of this stuff to be able to update the scripts, and then I run those scripts itself. Right? So you can see over here, I'm passing in the priority value, the host private IP, etc. Now, sometimes I want to be able to, I can have only one host or two hosts, this kind of stuff, right? So what it's doing is that it's writing this, and then it's running this script, and then starting keep alive D, right? Where's this? Yeah. Okay. Now, how do I know what's the IP address? At the time of Terraform writing the files to the configuration, it's not, they don't know the IP address, right? So what we do is that the Terraform provides you with something called a null resource, right? And then what we do is that we sort of listen for this file to exist. So every 10 seconds, it checks whether this file exists. And then the moment it's finished, then I trigger a new one. So you can see there's a dependency between this and the other one. And then I take this file, I write it to that instance itself. And then I specify the destination, and I run it, and that's it. Right, so when I run all of these across all the 3 instances, so now they know each other, right? So we can check this. Oh, sorry. Okay. All right, so saying that, all right, so it is master state. This is 81, right? Okay, and this one. Come on. All right, run the same command. Okay, now what I'm going to do is I'm going to stop the NAT on 81. Sorry, go to compute. I'm going to log out from here first. So I'm going to stop the NAT on 81, and then we will watch this one on 82 become the master, right? Okay. Right, so it's stopping. All right. It's not yet transitioned to master. You can see it's still in backup state. Now it's in master state. So if I curl Google, for example, from here, it's working fine, right? So I have a few more stuff, but I'm running out of time. If you guys want to talk a bit more about Terraform, infrastructure as code, this kind of stuff. So, so what I encourage you to do is head to our GitHub page. So we have a pretty nice bunch of samples that helps you to do this kind of stuff. So we have Ceph provisioning, cluster, and this kind of stuff. Similarly for PaaS, we have some examples as well. If you have any questions, we can have a chat outside. That's it. All right. Thank you very much, and I hope you enjoyed it.